Simpson 3-8 method. As we know that Simpson 3-8 method is based on a interpolation. So first we give the geometrical interpretation of a Simpson 3-8 method, then mathematical derivation of a Simpson 3-8 method, then error which occur when we solve the numerical problem based on using the Simpson 3-8 methods, and we solve some numerical problem based on all three methods, means a trapezoidal rule, Simpson 1/3 rule and Simpson 3-8 rule, and also solve one numerical problem based on a application of a numerical integration. So first we give the geometrical interpretation of a Simpson 3-8 rule. So Simpson 3-8 rule, Simpson 3-8 methods, also known as a Simpson 3-8 methods. So suppose there is a n plus 1 ordinate is given on x-axis. Suppose the values of these with the x0, x1, x2, x3, and similarly here we assume that here xn minus 2, xn minus 1, xn minus xn, and here another value xn minus 3. So this one is the x-axis, and corresponding values with the y0. Here suppose this one is a y0, and next one suppose this one is a y1, next one is a y2, and suppose this one is a y3. So suppose here these are the values corresponding to the x0, x1, x2, x3. The values of means y that we are going to integrate, means what is the problem? Problem is this one, integrate x0 to xn y dx. So I equal this one. So what is our aim? Our aim is to find out integration from x0 to xn of a function y dx. What is the given? Given at x0 what is the value of a y, at x1 what is the value of a y, at x2 what is the value of a y, at x3 what is the value of a y. Similarly, suppose here there is a yn minus 3, yn minus 2, n minus 2, and here yn minus 1, and here yn. So here, as we know that Simpson 3-8 method is based on interpolation. So here we try to interpolate the value using four values, means y0, y1, y2 and y3, means we interpolate a polynomial using four values. And as we know that if there is a four known values, then we are able to fit a polynomial of a degree 3. And so in this manner, so what's happened in Simpson 3-8? We use four values at a time to find out the area. Means we divide this one into a bunch of means a group of x0 to x3, x3 to x6, x6 to x9, x9 to x12, like this one. Then approximate a polynomial between y0 to y3, and what is the degree of a polynomial? Degree of a polynomial is a what? Degree of a polynomial is a polynomial of a degree 3. Means first we find the area between x0 to x3, this area. We find the area for this one. We find the area for this one. We find this area first. And here this is a polynomial of a degree 3. And suppose the function is not a polynomial of a degree 3, function is like this one. Then this one, this part create the area. this part generate the error. Generate the error in a first step. Similarly, when we try to find out the area from x3 to x6, also there is a chance of an error, and also we approximate a polynomial of a degree 3 from x3 to x6, and similarly x6 to x9, and last one is a xn minus 3 to xn. So this one is a geometrical interpretation how we solve any numerical problem using the Simpson 3-8 methods. So what is the mathematical derivation here? If a mathematical derivation so as earlier we discussed, first we divide the x0 to xn into a group of 4 points, means x0 to x3, means this integration I equal x0 to xn y dx divide into a group of 4 terms, means x0 to x3 y dx plus x3 to x6 y dx up to, and similarly we write one another term x6 to x9 y dx, and last term is a xn minus 3 to xn y dx. So first we find the integration of from x0 to x3, then x3 to x6, x6 to x9, then xn minus 3 to xn. So first we find the integration of this one, and in a similar manner we write the integration of this one, and last one. So what is the integration of x0 to x3? x0 to x3 y dx, as we know that this one is a method based on interpolation, and here we assume that these values, means x0, x1 reside at a equal class interval, means x1 equal what? x0 plus h, x2 equal what? x0 plus 2h, means the difference between x2 and x1 is a h, and difference between x1 to x0 is a h. So to interpolate this one, here we use any interpolating formula. So either we use forward interpolation formula or backward interpolation formula, because these are the two formulae, basic formulae which is used for the interpolation of a equal class interval. So for sake of a simplicity, here we use the Newton forward interpolation formula. And what is the Newton interpolation formula? We know that. What is the for here? So here we replace y by the Newton forward interpolation formula. x0 to x3 y dx is what? y0 plus u del y0 plus u minus 1 upon factorial 2 del 2y0 plus u minus 1 u minus 2 upon factorial 3 del 3y0 and I am not going to write all other terms. There is a reason behind this one, because we are going to fit a polynomial of a degree 3. Then if we going to and polynomial of a degree 3 and there is a 4 known values, so only we able to find out up to a third order forward differences. Fourth order onwards, the value of a difference becomes 0. That's why I am not writing here del 4y0, means a term of a del 4y0, del 5y0 and so on. And now if we closely observe, this one is a function of a u, this one is a function of a u, this one is a function of a u, but we are going to integrate this one with respect to x. So for this one, there is a need to convert this integration in term of a u. So we know that what is the value of a u? U equal x minus x0 upon h. So what is the value of a dx? dx become h du. H du, and what is the lower limit? Lower limit become, if here if x, then this one is x0, then what is the value of u? U become x0 minus x0 upon h. X0, here we put x equal x0, then this becomes 0. This one is a lower limit. Lower limit. Lower limit. And what is the upper limit? Upper limit. Upper limit become what? Upper limit, if we put x equal x3. So this become x3 minus x0 upon h. And we know that these ordinates have equal class intervals, so x3 be the x0 plus 3h minus x0 divided by h, and this one is the 3. So what is the lower limit? Lower limit be the x0, and lower limit becomes 0 and upper limit becomes 3. So here if we write means x0 to x3 y dx equal what? If we integrate this one 0 to 3 y0 plus u del y0 and v del y0 plus u minus 1, here we write in a simplified form, this become u square minus u square minus u del 2y0 plus, here we write about 3 factorial means 1 by 6 inside, this become u cube and this become minus u and minus 3u because it be multiplied by this one u cube minus u square, and it be multiplied by minus 2 u square and plus 2u, and this become plus 2 del 3 by 0 hd. So now we integrate this one. If we integrate this one, what is the value? Value become, here h become outside, inside, what will happen? y0u plus u square by 2 del y0 can be written as a what? Del y0 can be written as a y1 minus y0 and plus 1 by 2 integration of a u square become u cube by 3 minus u square by 2 del 2y0, here we write del 2y0, similarly plus 1 by 6 and integration of this one u4 by 4 minus 3u square by 2 plus twice u del 3 y0, and what is the upper limit, lower limit? 0 to 3. So now after simplification of this one, what is the value? We simplify this one, what is the result? Means if we simplify this, expression, then and putting the lower and upper limit, and in place of a del square we write what? E minus 1 ka whole square, and in a del cube y we write in place of a del we write e minus 1, because what is the relation between shift operator and forward difference operator? So here this become h y0u u plus u square by 2 y1 minus y0 plus 1 by 2 u cube by 3 minus u square by 2 Del 2 y0, this one, in place of a del, we write what? En minus 1 pi square y0 plus 1 by 6. 1 by 6 inside u to the power 4 divided by 4 minus 3u square by 2 plus twice u. Del 3 is replaced by e minus 1 ka whole cube y0. And what is the upper and lower limit? 0 to 3. So, what will happen here? So, if we simplify this one using the shift operator, if we simplify this one, e minus 1 ka whole square means e square minus 2e plus 1. If we operate the e shift operator with y0, e y0 become y1, e square y0 become y2 and y0. So, and similarly, if we expand this one e minus 1 ka cube, e minus 1 to power 3, then e cube y0 become y3, e square y0 become y2 and e y0 become y1. After simplification, we get what? We get 3hy8 inside y0 plus 3y1 plus 3y2 plus y3. So this one is a integration from x0 to x3, x0 to x3, x0 to x3 what dx. So in a similar manner, if we write the value of what? If we write the value of x3 to x6, x3 to x6 y dx, this one equal 3h by 8 inside. Now this one start from 0 to 3, this one start from 3 to 6. So in place of a y0 we write what? y3 plus 3y4 plus 3y5 plus y6. And in a similar manner, what is the value of our last integration? Value of a last integration means xn minus 3 to xn y dx equal 3h by 8. This one become what? This one become yn minus 3 plus 3 yn minus 2 plus 3 yn minus 1 plus yn. So in this way we find the value of integration of this part, and this part. Now putting the values, all the values here and simplify, then we get the required result, required formula for the Simpson 3. So just we put these values and simplify, then we get the required result. So x0 to xn y dx equal, what is the value for this one? 3h by 8. As in a previous means earlier we solved 3h by 8. This one become inside y0 plus 3y1 plus 3y2 plus y3, and integration of this one 3h by 8 inside y3 plus 3y4 plus 3y5 plus y6, and last one is integration of last term 3h by 8 inside yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. So if we simplify this result, then what will happen? The final result is if you closely observe, the first term and last term occur one time, and the multiple of a 3 means y1, y2, then y4 and y5, and y3 occur 2 times, then y6 occur 2 times, then 9 occur 2 times, means in a multiple of a 3, if means the value of a y subscript in a multiple of a 3, this will occur in a 2 times, and all other except the first and last term except with multiple of a 3. So what is the formula? Final formula become this one, means if we write in a here, not here, if we write here x0 to xn y dx equal what? 3h by 8. 3h by 8 become outside, inside, first and last term, sum of a first and last term, plus 3 time of what? y1 plus y2 plus y4 plus y5, and last one is a yn minus 2 plus yn minus 1, and plus 2 time of what? Multiple of a 3 is y3 plus y6 plus y9, and last one is yn minus 3. Yn minus 3. So this one is a what? This one is a Simpson 3/8 formula. So this one is a what? This one is a final form of a Simpson 3/8 formula. Simpson 3/8 formula. So this one is a Simpson 3/8 formula. So to solve any numerical problem, there is a need to remember this formula. Means h is a class interval between x1 and x0, and y0 will be the values corresponding to the x0, yn be the values corresponding to the xn, and y1, y2, y3, y4, and so on is the corresponding values x2, x3, x4, and so on. So this one is a what? This one is a Simpson 3/8 formula, mathematical derivation of a Simpson 3/8 formula. So Simpson 3/8 formula. Now what is the error? So error in the first step, I am not going to derive the means formula of error. As in a Simpson 1/3 method, as in a previous lecture, we derived the error formula of error for Simpson 1/3 method. Means first we write the Taylor series expansion, then we find the actual value in a first step, then find the approximate value in a first step, then what is the error after, means find a difference between actual value and approximate value. What is the error in a first step? Already I have write error. So I have already noted down the value of error in a first step. E1 is a what? Minus xn minus x0 divided by 6480. 6480 to power 5 y4 z. So this one is the error in a first step, means this part, this one is a sum of these two, this one and this one generates the error what? E1. And what is the amount of error? Amount of error is the minus of xn minus x0 to power 5 divided by 6480 y0 fourth derivative. Order of our derivative is what? 4. Similarly, if we find E2 this will become y3 to power 4. So in this manner, means E2 with the what? E2 with the minus xn minus x0 to power 5 divided by 6480 y3 to power 4. So in this way, we able to find out the error in the last step. Means the error in the last step become what? Means minus xn minus x0 to power 5 6480, and this become what? This become yn minus 3 n minus 3 fourth derivative. So how we find the sum of all error? This become equal E1 plus E2 and sum of all terms. So basically this one is the idea, means how we find the error in a Simpson 3-8 method. If we try to solve any numerical example, then what is the amount of error? So with the help of this method, means if we have with this formula, means if we have a value of upper limit and lower limit and function, then we find the fourth order derivative, and the value of a fourth order derivative at x0. This one is a y04, and then we find the power of this one 5 divided by 6480, and value of this one is a constant. Then we find the error in a first step. In a similar manner, error is second step, error in a third step, and so on. Then we able to find out the error after, means how many number of steps are there, means not a step, means how many parts of there, means if there is 1, 2 parts, then E1 plus E2, like this one. So this one is all about Simpson 3-8 methods. Now we try to solve a numerical example, which is a numerical example using trapezoidal rule, Simpson 1/3 rule and Simpson 3 rule. So we take very simple example. Problem is solve 0 to 1, 0 to 6, 1 upon 1 plus x dx by first trapezoidal rule, second one Simpson 1/3 rule, Simpson's 1/3 rule, third one Simpson's 3-8 rule, and compare with the actual result. Compare with actual integration, integral value. So this was the problem. So we try to solve this, means integration 0 to 6, 1 upon 1 plus x dx. So by trapezoidal rule, by Simpson 1/3 rule, by Simpson 3-8 rule. So as we know that this one must be a multiple of a 1. Multiple means the class interval, means a number of n, means the value of n is a multiple of a 1. And this one is a multiple of 2, and this one is a multiple of 3. So if we try to solve by all three methods, then it must be a at least multiple of 6. If this one is a multiple of 6, then we able to solve by the trapezoidal rule also, because 6 is a multiple of 1, multiple of 2, and multiple of 3. So here at least if we try to solve this one is a must be a multiple of at least multiple of 6. So here multiple of 6 means you divide the 0 to 6 into a 6 part, or 12 part, or 18 part, means a multiple of 6. 6, 12, 18, 24, like this one. So if you divide 0 to 6 into a 6 part, then you able to apply a trapezoidal rule, because here the n is a multiple of 1, Simpson 1/3 rule, means a multiple of 2, and Simpson 3-8 rule, multiple of 3. So here, what is the value of x0? x0 is 0, and xn is what? xn is 6. So xn minus x0 means xn minus x0 equal x0 plus nh minus x0. This one cancel out, xn minus x0, and this one is what? 6. Means nh equal 6. So how we choose the value of h? This one is very important to solve any numerical example. So If we solve by the trapezoidal rule, n must be a multiple of 1. If we solve by the Simpson 1/3 rule, n must be a multiple of 2. And if we solve by the Simpson 3/8 rule, then n must be a multiple of 3. So here we are going to solve by all three methods. So we choose a multiple of 6, because multiple of 6, this one is a multiple of 2, multiple of 3 and multiple of 1. So at least we choose the value of n is a what? 6. You may also choose the value of n is a 12, n is a 18. So this one is a, because n is a 12, then number of means inner values, inside values means the number of nodes is a larger. As the number of nodes is larger, we get more accurate value. So what is the value of h? The value of h here become what? 6 by 6, and the value of h become 1. Now we write the values of x0 is a what? We divide this one into a 6 halves, 6 parts, 6 equal parts. x0, x1, x2, x3, x4, x5 and x6. So the value of this one is a 0. What is the h? H is a 1. 1, 2, 3, 4, 5, 6. Because xn is a what? 6. And what is the corresponding value? This one is a x. Now y. What is the value for y? Y dx. Here y is a what? 1 upon 1 plus x. So 1 upon 1 plus x, if we put x equal to 0, then what is the value? 1. If we put x equal to 1, then 1 upon 1 plus 1, this become 1 by 2. 1 by 2. Now 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6 and 1 by 7. These are the values of y, and if we denote this one in notational form, the value for y0, y1, y2, y3, y4, y5 and y6. So these are the values. Now we almost done all the means calculative parts, means what the values of y and x is needed. Now we apply all the formula. What is the trapezoidal formula? Trapezoidal formula. We know that if for x0 to x6, y dx equal h by 2 inside y0 plus y6 plus y6 plus 2 times of what? y1 plus y2 plus y3 plus y4 plus y5. This one is a value. y5. Now we put the values of h. Now what is the value of integration? The value of h is what? 1 by 2. Inside y0 and y6, what is the value for y0? y0 with the 1. So 1 plus 1 by 6 plus 2 times of what? y1 means 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by y6 is not y6 is 1 by 7. So 1 by 6. So if we simplify this one, so we have already noted down the value of this one is after simplification. What is the value? Value of this integration. Value for this integration become what? Value for this integration become 2.0214285. This one is the result by the trapezoidal. Trapezoidal rule means the value for this integration by trapezoidal rule is what? 2.0214285. Now we write what? Simpson 1/3 formula. So what is the Simpson 1/3 formula? Simpson 1/3 formula, this become I equal x0 to x6, x6 y dx equal h by 3. H by 3 inside what will happen? This become y0 plus y6, first and last term, plus 4 time of a what? 4 time of a odd term, y1 plus y3 plus y5, plus 2 times of a even term, y2 plus y4. So this one is a what? This one is a Simpson 1/3 formula. So Simpson 1/3 method. Now we put the values of a what? Values of a y0, y6 here. y0, y1, y2, y3, y4, y5 and y6. Then what is the value? Value become I equal what? I equal h by 3. What is the value of h? H is a 1. 1 by 3. Inside the bracket, y0 plus y6, 1 plus 1 by 7, plus 4 times of a y1 is a 1 by 2, plus 1 by 4, plus 1 by 6, 1 by 6, plus 2 times of a 1 by y2 is a 1 by 3 plus 1 by 5. So after simplification, what is the result? The result become here. Put it down the value of a Simpson 1/3 method. What is the value? I become 1.1595973016. So this one is the result using what? Using Simpson 1/3 method. This one is the result using Simpson 1/3 method. Now we try to solve using what? Using Simpson 3/8 method. So we raise this one. So if we raise this one, then what is the result? Result become means for Simpson 3/8 method. This one is a trapezoidal rule. This one is a what? Simpson 1/3 method. Simpson 1/3 method is here. Write down the Simpson's 1/3 method. 1/3 method. Okay. Simpson 1/3 method. Now here if we find the value of y the Simpson 3/8 method. Simpson's 3/8 method. 3/8 method or rule doing 3/8 method. So what is the formula? x0 to x6, x6 y dx become what? 3h by 8. 3h by 8 inside the bracket, sum of a first and last term y0 and y6 plus 4 times of a what? y1 plus y2 plus y4 plus y5 plus 2 time of not 2 time because here 3 time of y1 and y2, 3 time, 2 time of a what? 2 time of y3, 2 time of y3. So this one is now we put the values of what? y0, y1, y2, y3, y4, y5 and y6. Then we get the result what? This one is 3h by 8. What is the value of h? The value of h is 1. So this become 3 by 8 inside the bracket. y0 means 1 plus 1 by 7, sum of a first and last, plus 3 time of y1, 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 6 plus 2 time of 1 by 4. So this one is a value. This one is a value for I. This one is a value for I. This one is a value for I. I have already noted down the value for after simplification. What is the value? This one is a 1.96607. 1. I become 1.96607. 96607 143. 143. So this one is the result. This one is the result after solving the Simpson 3/8 method. Now, what is the actual integration? So, what is the actual integration? Actual integration. Integral actual integral value. So we know that what is the integration of this one? Log 1 plus x. So I become log 1 plus x, and what is the upper and lower limit? Upper and lower limit 0 to 6. And if we put the upper limit, x becomes 6, this becomes log 7, and log 1 becomes 0, so this becomes log 7, and this one is the value for I. And what is the value for I? Log 7. We have already noted down the value for this one. The value for this one is a 1.945916. 5916. So here, this one is the what? This one is the actual value. So if we categorize this one into a different part, this one is the first part of the numerical integration, means this one. So now once we summarize how we solve the numerical problem, what is the example means a numerical problem. There is a need to solve this integration 0 to 6 1/1 plus x dx by the trapezoidal rule, by Simpson 1/3 rule, by Simpson 3/8 rule. So there is a need to solve all three methods, since in a trapezoidal rule n means number of interval must be a multiple of a 1, Simpson 1/3 method multiple of a 2, in Simpson 3/8 method multiple of a 3. But we are going to solve means by all three methods, then it must be a multiple of a 6. So the difference of upper limit and lower limit xn minus x0 with a what? nh equal what? nh equals 6. So what is the value of n? In case of a Simpson 1/3, it must be at least 2, multiple of a 2. In Simpson 3/8, at least 3, maybe 3, 6, 9 like this one. So since we solve all three methods, so this one is at least the value is 6, maybe the 6, maybe the 12, maybe the 18 like this one. So what is the value of h? Once we find the value of h is a 1. Then started from the lower limit 0 with the interval of a 1, with the interval of a h we write the values of 0, 1, 2, 3, 4, 5, 6. And corresponding value for y means here we put x equal to 0, then we find a y0, y1, y2, y3, y4, y5 and y6. Then we find write a trapezoidal formula. Then after calculation we find this value. This one is a value of integration by trapezoidal rule. This one is a value of integration by Simpson 1/3 rule. And this one is a value of integration by Simpson 3/8 rule. And this one is a actual integral value. And how we find the error? We able to find out the error by the difference of actual value and approximate value. Then we find the error by the trapezoidal rule, actual value minus approximate value by the Simpson 1/3 rule. Then we find the error in a Simpson 1/3 method, actual value minus approximate value by the Simpson 3/8 method. Then we find the error in a error by the Simpson 3/8 method. So this one is how we solve the any numerical problem using the trapezoidal rule, Simpson 1/3 rule and Simpson 3/8 rule. Now next we are going to solve what? Next we are going to solve a numerical example based on application. Suppose any particle is moving, we have a data, any particle is moving from certain speed, and we noted down the speed, velocity, not a speed means a velocity at a given time intervals. Means what is the question? A particle is moving and we noted down the velocity at a particular time interval. Then there is a need to find out distance covered by the particle from any time slice. So what is the problem? Problem is means any part, example, any particle is moving with following tabular value. So what are the values? Here we write a t in seconds and here v meter per second. These are the values. So here we noted down the values. What this one is we noted down the value for this one is 0 to 4, means in a interval of a 0. This one is a 2, then this one is a 4, 6, 8, 10 and 12. This one is in a seconds. This one is given in a seconds. So what is the velocity? Velocity already we have noted down this the value of this one is a 4, 6, 12, 4, 6, 12, not as 12, 16, 16, 34, 16, 34, 60, 16, 34, 60 and 94, 136. 94, 136. So this one is a problem. Problem is a what? Any particle is moving with following tabular value, means this one is a time, at a time 0, what is the velocity? Velocity is a 4. At time 4, what is the velocity? Velocity is a 16. At time 10, what is the velocity? 94. Now what is the problem? Find the distance. Distance moved by the particle, travel by the particle in 12 seconds. So this one is means how we solve such type of application oriented problem by the numerical integration. So how we solve this problem by the numerical integration means how we find the distance covered by the particle in 12 seconds. So we know that what is the V equal what? V equal ds by dt. V equal what? ds by dt. So what is the value for ds? Here s represents the distance moved by any particle, t is the time, v is the velocity. So if we simplify this one, ds equal what? v dt. So what is our aim? Our aim is to find out distance covered from 0 to 12 seconds. So what is our aim? Our aim is to find out s. S is a what? t0 to tn v dt. So with the help of this expression, be able to find out the distance covered by any moving body, any moving particle from t0 to tn with a velocity v. Velocity v is given at a different interval of time, then be able to find out the distance. So here, what is the value for t0? 0 is so if we formulate this one equivalent to this problem, what is the problem? There is a need to find out s equal 0 to 12 v dt means distance travel from 0 to 12 seconds, and v is the what? V is the velocity is given. So if we write this one is the what? This one is the T0, T1, T2, T3, T4, T5. This one is the T6, and corresponding value is the V0, V1, V2, V3, V4, V5 and V6. So you may solve this one by the trapezoidal rule also, Simpson 1/3 rule, Simpson 3/8 rule. By any numerical integration, by the method of any numerical integration, you may solve this problem. So suppose we solve this one by the Simpson 1/3 method. Simpson's 1/3 method. 1/3 method. Simpson 1/3 method. So what is the value for this one? By the Simpson 1/3 method, integrate 0 to 12. So there is a need to means that divide this one is a multiple of 2. So this one is already 1, 2, 3, 4, 5, 6. This one have a 6 interval, means 6 halves. There is a 6 halves. So n is a what? N is a 6. This one is a multiple of a 2. So we able to apply what? Simpson 1/3. As well as we also able to apply a Simpson 3/8 method, because there is a 6 part. Also we able to apply what? Trapezoidal rule. But here we apply a Simpson 1/3 method. So V dt equal what? H by 3. H by 3, velocity at the initial value, velocity at last value. V12, V0 and V12 plus what? Plus this become what? This become V0 plus V12 plus what will happen? 4 time of V1 plus V3 plus B5 if we talk about this one is not in a 12 part, this one in a 6 part. So first and last be the what? V0 to V6 and 4 time of V1, V3 and V5 plus 2 time of V2, 2 time of V2. So if we put these values, means what is the value of H? If we closely observe this data, this one is given in a class interval of a 2, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12. So here this become what? This become H is a 2, so 2 by 3. This one is a V0, V0 is a 4 plus what is the V6? V6 is a 136. 136 plus 4 time of V1, V3 and V5. V1 is a what? V1 is a 6. 6 plus V3 is a 34. 34 plus V5. V5 is a 94. 94 plus 2 time of V2. V2 is a what? V2 and V2 as well as V4 also, because this is also a term of 4. V2 plus V4. This one is the formula, V2 and V4. So 2 time of V2 is a what? V2 is a 16. 16 plus V4. V4 is a what? V4 is a 60. 60. So if we simplify this one, what is the result? Result become 2 by 3. 2 by 3 inside this become 140. 140 plus 4 time of 3, 4, 40, 40 and this become 94. 94 and 40, this become 134. 4 time of 134 plus 2 time of 76. 76. So if we simplify this one, 2 by 3, 2 by 3, this one is a 140 plus 16, 3, 5 plus 2, 152 and after simplification of this one, 2 by 3 of what? This become this become what? This becomes 6 to 8, 8, and this becomes 5, 3, 8. 5, 3, 8 plus 4, this one is a 12, 12 and 1, 2, 7, 1, 8, 8 to 8. And if we divide this one, this become what? 3 2 is 6, and this become what? This one, this one. So if you multiply, this one is a what? 2, 5, 5, 552 meter. This one is the result. 552 meters. So what is the result? Result is a 552 meter. This one is the result. This one, I have already noted down the value for this one. Value for this one is already, we checked the value for this one. This one is a 552 meters. So 552 meters. So what is the distance traveled by any particle moving with this tabular value? This one is a what? 552 meters. So this one is a result. So you may also solve this one by the Simpson 3/8 rule, and you may also solve this one by the trapezoidal rule. So this one is all about numerical integration, means trapezoidal rule, Simpson 1/3 rule and Simpson 3/8 rule. So next we will discuss about how we solve RDA differential equation by the numerical methods.